Hello and welcome to our group's video on the bottle rocket project. In this video you will see the analysis done to determine the thrust profile, an expression for the navigation of our rocket, images of our design, and an analysis of what went wrong when we actually constructed and launched our rocket. While our rocket did not hit the target, we had a lot of fun with this project.
As you can see from these equations, there are many values dependent on one another, such as the rate of mass leaving the bottle rocket, the pressure changing with time, and the exhaust velocity at the nozzle. Through much research regarding fluid dynamics, which is where we found a relationship called Bernoulli's equation, which, if we're being completely honest, we don't necessarily understand, we were able to create an expression, albeit ugly expression, for the thrust of the bottle during its ascent.
Taking this thrust profile and adding on the additional forces of the weight of the bottle and the drag force, as well as considering the launch angle of the rocket, we devised an expression for the first half of the launch, which we then plugged into MATLAB to solve. We then used those results to find the rest of the distance that the bottle rocket would go using projectile motion. This then gave us an ability to have an estimate for how far our rocket would go.
Our initial design featured 4 fins that were located further back on the rocket to increase the stability of the rocket's path. The fins were important to be thin when looking at the rocket head-on, as this area would have an effect on the drag force that the rocket would experience in flight. The larger the area, the greater the drag. Additionally, a nose cone was added to the front of the rocket to also improve the aerodynamics of the rocket. At first, we had no weight located in the nose cone/payload, and this proved to be a problem during testing.
For testing, we took our initially designed rocket and launched with a consistent volume of water being about 20% of the bottle's total volume. We then tested for varying pressures and angles. However, our rocket proved not to exhibit a stable flight for any of the different scenarios. Thus, we decided that our rocket would have to change in design, which meant to us putting weight in the nose cone to prevent our rocket from tilting upwards and then flipping around during flight.
The goal of constructing our second rocket was to put weight in the nose cone and better secure our fins to the rocket. We had intended on using a tennis ball in the nose cone to give adequate weight to the top of our rocket, but unfortunately, one could not be located in time. Therefore, our nose cone consisted of unevenly stacked cardboard pieces, lots of paper, and a lot of tape, creating a slightly off-center tilt to our rocket. The consequence of this decision was shown during the final launch of our rocket.
During the final launch of our rocket, prior to the actual launch and the setup portion, one of the team members hit a fin and caused it to become loose from the overall structure of the rocket. This ended up creating additional issues during the flight, which we knew were going to happen, but had no way of fixing at Penn Park. We launched our rocket at 40 degrees, filled it with water about 20% of the total volume of the bottle, and set a gauge pressure of 60 psi. During the flight, we saw that our rocket turned a hard left at one point, and a fin popped off as well, causing our rocket to have an unstable flight. We attribute the turning of the rocket to be the off-axis center of mass, which was caused by the unevenly distributed weight in the nose cone. Since the center of mass was not in line with the center of pressure, this created a moment during the flight which caused the rocket to veer off course. The fin popping off just added even more problems, with the rocket becoming more off balance and asymmetric in terms of weight distribution, as well as the fact that the fins, which were supposed to promote stability, were now no longer useful.
There were many things that we couldn't account for, such as wind direction and strength during the launch, which was a factor we observed that caused other groups to have off-course flights. However, we believe that a majority of our problems were self-induced during the construction and pre-launch phase. Additionally, the launching device did not have a launch ramp, which attributed to our bottle having a slight wobble the moment it was launched. However, overall, had we been more careful with the setup and actually used a tennis ball in the nose cone, we believe that our rocket could have flown straight and ended up closer than the 33 feet our rocket ended up being from the goal.